Welcome back to Made of Wires. We're decompiling Castlevania Symphony of the Night. Go to soten.z.dev for more info. You'll find a link to Discord. You'll find a link to GitHub. And I'm going to snooze this first ad. Too early. So maybe it's a good idea. Get it out of the way while nobody's watching. If you are new to decompiling Castlevania Symphony of the Night or Made Up of Wires, the Made Up of Wires show, we are trying to get a matching decompile of Symphony of the Night, and that means what we want to do is reproduce C code that will compile back to exactly what was shipped on the Symphony of the Night game discs. We're targeting a couple versions to start, but hope to get to basically all of them eventually. We're looking primarily at the PlayStation 1. That's usually the starting point, with the long library, which is what we're going to look at today. We're also going to look at the PSP version as well, specifically the EU PSP version. Why the EU PSP version? Because that was the first version, at least that I'm aware of, that has multi-language support. And so it's a little different from the other versions. How many versions of Symphony of the Night are there? There are a lot. I actually have a slide I'm creating with the lineage of Symphony of the Night, and there's about a dozen versions of Symphony of the Night. But fortunately, most of them are derivatives of just a handful of versions. So we're going to be looking at long library, and we started yesterday looking at the shop. On Monday, we were doing some stuff with the PlayStation SDK related to the CD functions that ship with it, specifically the ones that are compiled into the Symphony of the Night game files. And then the previous week, we had found the chair in the outer wall, and most of the overlays for stages share a lot of the same entities and code. So we looked at where that was in the long library, and the long library version differed slightly from the outer wall library, but except for some debug statements, it was the same code. And so we could share that code with a few ifdefs, actually just one ifdef. And that code actually compiled cleanly for the PSP as well. And then we found the library shop, and we're looking at that yesterday. There's one function in the library shop related to the inventory, and we were looking at that, and then the layout of the inventory itself in the library overlay. And I'm going to keep going with that, that inventory data. Mozilla and Eldritch were kind enough to show up. They work on the Soten randomizer, soten.io. You can find them in the long library Discord. And they had, from their hacking pre-decompilation, they already knew the general layout of the store inventory, because they randomize that when you're creating randomized seeds. And so they were able to provide a lot of insight for that, making that process a little easier. So we're going to continue on with that today, and we're going to take that that inventory data and convert it into an array of structs. And what that will allow, and I've shown this a few months ago as well, but that will allow conditional compilation where at compile time you could choose to modify that inventory list. And it one of the things I think is interesting from a modding or ROM hacking perspective is how would we do some of the things when we have the source code for the game that the randomizer community is doing without the source code? And is it easier? Would it be faster? Are there things that we can do? And last time, what I showed was starting equipment and how we could randomize starting equipment at compile time. And one of the interesting things about that is we can change some of the logic then around starting equipment. Specifically, the change that I made was when you reach the death room, if you don't do a death skip, he steals your inventory. And what inventory can he steal? You could potentially compile a different implementation of how he steals, the ordering of how those icons come out of you visually, and a bunch of different things. So we're going to look at that the data for the long library shop inventory. And we have to do a little bit of splitting before we can do that. And splitting is one of the harder things, I think, when doing this. When this game was originally created, it wasn't all one big C file, but when we extract the source using splat, that is basically what gets generated. One long C file. It includes assembly versions of all of the implementations of all of the functions that are necessary. And then based on the best available data, splat will give us some information, but then based on things that we see across different stages, we have to decide where we want these splits. And so one of those was the chair. The chair is in a unique file, and that can be shared across different stages. And then that way, you can import that chair without having to know what comes before or after it. And so now we're going to work on splitting the library shop out as well. And right now, that's just in a huge C file called first C file. Why is it called first C file? Because it's the first. And I already made some notes here, I believe, but am not positive, that the first split comes around here. And there's a, we worked on this 29C4 function. Looking at the implementation of the function below, this 2BE4, this is the shop entity itself, the main state machine for the shop, as far as I can tell. It calls this other function to get inventory information. So this helps pull out whether or not items are available based on your level and other things like that from the shop data. So this 29C4 function is what we were working on yesterday. Didn't get it quite decompiled, and there's still a few tricks to find there. And then this other function, 245C, is also used in this shop inventory function. It doesn't match anything from another overlay, but it also is used in several other functions in this file, and I'm not quite sure if it's part of the shop or not, but I'm going to include it for now in the shop. So the end of that split is the end of the shop entity. As far as I can tell, this following function down here, which is B3EC8, excuse the line split, we're here on line 889. As far as I can tell, that function is not related to the rest of these shop functions at all. So I'm going to split there. That may or may not be a good choice, but we'll see. And so the first thing I'm going to do is split this the C functions, and then I'm going to split, try to split the data. And that may or may not prove difficult as well. We'll find out. So we already know that some of the RO data that's coming in here at 801 AC F14 is going to be associated with functions after this split. So we need to take care to split that as well. And basically we're creating the different segments that this overlay was compiled into. So if you're not familiar with how C programs are compiled, typically you have several different sections, and you can see what those are in this splat config. Data is first. So data is things that are loaded into memory but can be changed. So they're not or constant data. RO data, which is const, it's data that can't be changed. A lot of time this is static strings and jump tables. And then there is our C file. This is called text. The segment is called text. Why is it called text? I don't know. And then BSS or SBSS, which is uninitialized data. And for PlayStation games, that uninitialized data is exactly the size of whatever data is needed. And so all of these things come from a single C file, but we don't know exactly where those splits are. Do we have do we get a Hello World example and see? We can, if you'd like. A C file or a C program can be relatively simple. There is a few things that are different when you're targeting embedded systems versus operating systems. And I mentioned this before as well. We don't have dynamic loading. So when we need libc, for example, which is our core set of functions, you have to compile those in statically into the game. And that's what's done here. And we have that to decompile as well. C, a lot of languages that we use today are derivatives of the C syntax. I could go over some basics of C, but I'll skip that for today. And hey, if you want to know more about C, chat, comment, like, subscribe, do all of the things. So the first thing that I need to do to split at this particular segment is find the address find the address of this function, which happens to be the name of the function because that's what Splat decided to auto-name it, which is a good idea. Entropy Gravity Well saying, why don't we have the option for memory monitors in modern computers? Are you talking about like hardware watchdogs, like ECC type stuff, or something different? Or just being able to snoop and dump any RAM that you want, like in mini computers of yesteryear. So my first split and new segment, I have to calculate the offset here. I can do that in two ways. I can look at what memory location this overlay starts at, which is listed as the VRAM number, 801800, and then subtract that from the offset of the file, or I could open that file and it would give me the offset as well. I am going to choose to just do the subtraction in my head because it's pretty straightforward. Yeah, it is kind of a bummer, and I think we're getting further and further away from low level, even like virtual machine access, which is a little bit of a bummer. I've been thinking about that a lot. I've been a Mac user for well over 20 years now, and the reason I originally moved to the Mac platform was because it was a commercially supported Unix on RISC hardware, long battery life, really great hardware. Still have great hardware. But Mac OS, still being a Unix, is just like lockdown. And the things that I like about computing are slowly going away. Yeah, and I don't know how I feel. Like, I'm not gonna lie, the the M series Macs are super fast, and that's awesome. What was nice about I had Macs back in the PowerPC days, and still have a G5 in the room next to me, just for fun. And it's nice having that exotic architecture. ARM's not terribly exotic anymore, but not having the M1s have this weird. They have some hardware compatibility for emulating x86, but you don't have x86, and so things like VMware, I can't run a Windows VM for the random thing. There's a PS4 package extractor that I want to run, and I have to have, something else other than the Mac to run that. I don't know. Anyway, so I'm creating a new segment here. It's going to create when I extract this, it's going to create a file called unknown33fb4. I name that after the offset. And that new file is going to contain all of the includes from here on down. There are some functions that are decompiled here, so I probably will take those and just copy paste and fix the path here. The name of the file will be in the path. And then we should be able to compile it. The next thing I'll have to do, I'll actually do that while I'm here. I know that there's going to be RO data, so I'm going to create a new RO data segment as well. And that RO data is going to start at 801 AC. So this A starts at 2. So that's going to be 2CF14. And that's going to come from that same 33BF4 file. Unfortunately, these segment splits are relatively disruptive. And so I may try to get this submitted by PR relatively quickly, because the longer that I keep this in my branch, the harder it will be to merge in later. So I'm going to use splat, which is used to split and generate the assembly from these files. So splat, I'm going to use split, and then this splat configuration that I have, and that will create a new file for me, and it'll also tell me I think there's some additional RO data splits at these addresses, and those are good to note because they probably mean that we have other ones that we need to look for as well. And now I should have, like I said, I should have a new file called unknown33fb4, which I do, and it has included, or it has auto-generated a bunch of these include ASMs. The path is wrong for various reasons, so I'm going to fix that just by pasting in everything below this. And then replacing first C file with our new file name. And if I did everything correctly, I should be able to compile. So first I'm going to, I'll run make extract. Which should pick up that change in stlib. And something failed. That may not be. All right, so it can't, there are some files that look like they weren't extracted. I'll run that again. And just make sure that I did all the things that I need to do. All right, so I am not seeing these files get generated. So I'm going to clean and run it again and pick up on chat. Yeah, that's so Entropy Gravity Well said there's no chip that compares to M4. I think, yeah, Apple is at a crazy competitive advantage at the moment with their chips, and it definitely is surprising. I don't know what is going to stop them. I would think that NVIDIA would have the capabilities, and maybe AMD would have the capability of catching up in like the power to performance ratio. Yeah, we're still not. These are not being generated. So let me undo this change. I am going to comment this file out. So this new file will get compiled regardless of whether it is listed in the Splat configuration or not. So I need to make it something that's compilable. So Splat did create the file. But as I mentioned kind of at the beginning, this splitting segments is often, I find, error prone. So I'm going to make extract again and make, and this should have reverted to what it was. And this is, unfortunately, I need these segment splits before I start working on data. Otherwise, that will, there are ways to get around it. It'll just be more difficult to do. And so this seems fine. So what I'm going to do now, just to double check my work, I mentioned that, and I'm going to get this going faster. I mentioned that you can get the segment data or the offset from the file itself that gets split. So I'm going to go to the ASM directory, stage, library, non-matching, first C file. And then I'm looking for 801B3. 801B. Oh, where are you? Not sure why it's showing up in matchings. All right. So, well, yeah, okay. So the first thing I see is I did screw up the offset. I grabbed the offset from the wrong function. I grabbed the offset from 3FB4, which was wrong. So I'm going to grab the right offset. I make these mistakes to educate everybody, of course. And fix the name of that file then. And then fix it up here as well. It is possible, and I probably should look at this as well. It is possible that there is RO data in some of these other functions as well. So before I get too far, I'm going to look at FB4. And basically, I'm going to look at all the functions that come before this include RO data down here, because they might have some RO data just embedded in the file itself. B401, B408. So far, nothing. Unified memory, I have mixed feelings about that as well. I mean, who wouldn't like the additional speed? For sure. So it does look like I don't see anything before this RO data down here. So our RO data at CF14 is still correct. But just to make sure, I will open that file and grab the offset there so I don't screw up. To CF14. Yep, I got that as well. All right, so take two, this time at 33EC8. So from a performance perspective, unified memory is awesome, but obviously it comes at the expense of not being able to upgrade later. And especially, again, with Apple, you pay out the nose for memory. You always have paid out the nose. And so, 10 years ago, 5 years ago, when you could just get some, buy RAM from anybody, buy, the fastest RAM you can, the biggest RAM you can, you could upgrade for relatively cheap. So that's typically what I would do, just buy the lowest RAM configuration and then max it out aftermarket. And unified RAM just means you're paying up front, and yeah, I guess I don't know how I feel about that. I feel like RAM on laptops has not grown with everything else. I've had 16 gigs of RAM since, 2009 or so in a laptop. And now I just have 32 gigs 15 years later. Okay, so now we should have this unknown 3EC8 file. I'm going to delete the other file that was created that I incorrectly made so that it doesn't screw things up when I'm compiling, and then find my split location again. And try the same thing, and hopefully I do better this time. We're going to include lib.h. I don't really like that this is named lib because I think of libraries like C libraries. When Mr. MIDI mentioned it the other day, I had no idea what he was talking about. Yeah. Yeah, I mean, okay, so I guess that's the way of it. I'm old, an old curmudgeon, set in my ways. Now let's try again. Let's see if this works. Library failed. I'm going to make sure that this is recompiled and this is recompiled. And there could be something else that I missed. So let's do a diff. So the first signs of the split error are happening at 6C0. That's not, that just means that there are offsets that are broken later on. We want to find the offsets that are around where our split is. And so 2B930 seems like a reasonable place, but those look like, it looks like 4 bytes are missing somewhere. And so I need to figure out if those 4 bytes are coming before or after my split. And just to remind myself, my RO data split was at 2B938. So 2B930 is something that I can search for. And so at 2B930, I don't see anything except for this size difference or offset difference, which is the 4 bytes. So we need to find 4 bytes, and we can go down to the end. And then shake our fist at the sky. Where are our 4 bytes? So I'm going to do 2 things to find my 4 bytes. I'm going to look at this one more time and see if I can find one of these segments that, yes, here it is. So the missing 4 bytes are at 2CEE0. We have these 4 bytes here, and they don't exist down here. So how do we get our 4 bytes back? Oh, there's actually, oh, that's different. Okay. Oh no, I'm wrong. Those bytes are there as well. So I'm looking for segments that either start differently or have something different along the way. So for example, this 2D950, there's 4 bytes down there. We can look at the other one, and that's there as well. Oh no, it's not. So 2D958. Near the misspelled dummy set. So let's see what's happening there. 2D95C. so at the end of this table, in the original split, there is some data. And that appears to be missing. Let's see where the So this is part of a jump table. Oh, this is coming from, I don't want the matchings. All right. This is part of the jump table for this function. And this, what may have happened, unfortunately, I may have to do some additional work here. What I think is happening is previously the split just happened to fall on an alignment boundary, and so everything just worked. And when I split this, the split was not aligned, and I have this function down here, which is generating its own RO data, which is perfectly fine, but that RO data now is not aligned correctly, and so we have to force the alignment. And the way to force the alignment is to split the file. Okay. And it looks like this BDA340 may have to come with it because it is called as well. So I'm going to split again. This function is called as well. So basically I want to find all the functions that are included with this one. This one is not. So I'm going to split here as well. And now I get to do the same things over again. So I know that this jump table is necessary. What I don't know is if these strings are included as well. I don't see them there, so let's find where the last string is used, and hopefully it's at some function above these. So BDAE4, so those strings are included as well in that function. So it looks like this A0 is where we need to split. So a new split, this time at 3D268. And then RO data split as well at A8. 0, 2D, 8A0. Hey Antoine, good. How are you doing? I am struggling with some segment splits at the moment, but we'll get through them. The thing about some of these segment splits is they get worse until they get better. And as Winston Churchill once said, if you're going through hell, keep going. And so that's what we're doing. So we should get a new file again, this time split here. And so this gets complicated really quickly. And when it's when this complexity is growing, again, you want to make sure that as much of this as possible gets merged in quickly, because it will conflict with other people's changes. All right, so I think that should be fine, and let's cross fingers, hold on to your butts. And we have something else that's broken. A bunch of, what's the header? All right, so we have undefined references to some data at D868, which should be RO data from the previous split. Yeah, it isn't 33EC8. 268. And an undefined reference to a jump table at 8888. So that may mean the split should have been earlier. So let's do that then. 8868 is the earliest split. Hey, Mr. MIDI, I'll give you back. Failing to do splits. Still undefined references. Still failed. Okay, so let's see if that failure is different, or better or worse. Before the failure is at 2D9 something, 2D590, 2D950, 2D9. And 2D950 looks correct now. So what I think I'm going to do is keep this second split get rid of the previous one. And see if that second split is correct. And then debug the first one if that's the case. So I have to go take all of these functions, and they're going to go back into first C file. And as long as I don't do a clean, that other function will compile fine. And I can keep these incorrect paths for now as well. Let's see if I got this one correct. Oops. Nope. All right, so what you do then, when nothing is working out and everything is broken, you restart and do it again. And so I'm going to get rid of all of these segment splits that I added and do a sanity build with that reversion. And that works fine. So I am doing something wrong. All right, so what I expected to have happen was 268. That our data would split here. This is on a 4-byte boundary, which should be reasonably safe. We have the RO data in the file, in the assembly file. Oh, yeah, and it is the first thing referenced. What I can look for is, what should I look for? The function immediately before this one. Just double checking. Actually, first I'll go through and find this function as it was originally split, and it's split the same, or the RO data associated with it is the same. So that seems pretty safe. So I'm going to try it again. Glutton for punishment. I think that other split may be the issue, maybe. And our text offset is at 3D268, which is what we have as well. So let's try again. Not a lot of code today. And I need to go back to first C file and make sure that I'm not, so what happened there was at the link step, both first C file and the new file that's being split all have the same functions. So I need to go find D268 and get that out of here. And we fail. Bummer. So I might not be able to do what I wanted to do today, because I've been doing this for about an hour and making no progress. So somewhere we have an alignment issue. And the diff near the top, I'm going to try using vbin diff instead of my tool. I should be able to do this. I think this is written this way. Yeah. So vbin diff will provide a little more detail. And so the first, is this missing data? So there's this 2E padding. 4 of those bytes is missing, or 4 of those bytes are missing. The addresses on the side, though, are not matching. This is not like my... Why aren't the addresses updating? All right, I'm gonna do this one more time and see if there's anything obvious. A lot of these are just going to be offsets that are now wrong. And so what we need instead is where the data is missing. And usually vbin diff makes that a little easier to find. In this case, not. So I'm going to start here at 3E50. This may, again, just be offsets as well. Okay, I'm failing miserably at this, so I am going to revert this change as well. There's, yeah, something I'm missing going on. I find it usually easier to peel off the beginning or end of one of these files. I'm doing something that I'm missing. I'm going to look at one more thing before completely giving up, which is looking at the 2068 data, which gets us down to the first RO data. And yeah, that's really unfortunate. Well, so Mr. Mitty is saying that basically um, it is somewhat of a Zen process of splitting. Um, I would say 3 out of 4 times it goes exactly as you'd expect, and that other 25% is just like this, where it doesn't seem like there's an obvious reason um, why some offset's getting injected or not. Um, it's usually a little more straightforward to split right at a function with a jump table, but that's not always the right place to split either. And we could look at actually at the splat output and see what splits it suggests, because it will tell us where it thinks splits are, and I've just been ignoring that. So maybe there are some here that would make this a little more obvious. So it thinks 82C and 848. Let's look at those. So those are all so those are kind of in between where I was splitting. So it may be that I should be splitting at 848 and pulling in the RO data there. So we try that. And then in first C file, I need to see if there's an include RO data that would fall in this range. And this is at D774, so this is outside of that range. So I'll give this one more shot. And so this may give us a hint as to what is going on. So BE, B0 here. It's possible that there should be a split here, and that may or may not be causing our alignment issues. So the RO data that's coming from this 2D48 basically is required for this BBEBO function. So let's try doing the split there and see how that goes. So this will be at 3B BE B0. Last one. And then we'll go back to some code. should be able to get away. None of this is decompiled, so we should be able to get away with just these. And get rid of the ASM-US prefix. And so that split worked. So we peeled off some, but not everything yet. I will do a split again. Split 2D ABO is the next earlier split. No, it's afterwards. And where does that get us? Not where I want to be yet. Okay, so what can we do? I really want to get the split at 3.3 EC8, and maybe we have enough to do that now. That would be C3 EC8. Where are these? Library. B3 EC8. Okay, we'll try it one more time and see how this goes. So what I wanted to split to begin with anyway. We could do two things, maybe just to so I'll split there. That file I think exists already when I created it before. So we need to go down to AB4 as our last function. And get rid of all of these. And that works. Okay, so I should have looked at the splat output originally. Okay, so what I actually wanted to do though was none of this at all. I wanted to get the split for the shop, and my theory was that the shop was going to split here at 245C, and so now we can go ahead with that. So we need the RO data for the only RO data that's coming with us is the RO data for 2BE4. Actually, there may be some strings here as well. And so let's see if we can get that one as well. Yeah, we do have some strings. So our RO data is going to split at 2CE78. Let me just double check the two earlier ones. I don't think that there is any RO data in any of these. 29C4. So, non-matchings. Nothing there. And then 245C. Nothing there. All right, so let's try again. 2, 4. So we're going to split at 2C E78. And I'm just gonna name this one right out of the gate. Call it the shop. Call it shop or store. What do you guys think? And the offset here is going to be 3, 2, 4. So that will give us our shop file. Oh, my split was wrong. My split should have been at 245C. I don't vim so good sometimes. And so I'll pull these out into the new file. The advantage of creating a new file, obviously, is when people do the git blame, you're the author of everything. I'm kidding, of course. So I'm going to keep these names, as long as I don't clean, I'll still have the extracted version with these paths, and that should be fine. But I will need to fix that, obviously, before checking anything in. And here we go. It built. Happy day, happy day. Okay, so we have a few things now. The whole point of doing all this, the whole terrible, awful point of doing all of this was to get the data that is related to this function and split that. And here we are, an hour and 15 minutes in, and I've not even touched the data yet. So what I want to do is get my notes. The data I want is this list here. So all this splitting, and like I said, I want to get to the data. What does that mean? We have these different segments, and when you build a C file, it gets built to a .o elf file, and in the .o file, we have all the same segments: data, RO data, C, CSS, and then when those get assembled into the final overlay output, this list of segments in the splat config basically says, give me the shop object, give me its RO data segment. I'm going to put it at offset 2C E78 in that file. And if you compiled everything to the right data and your compilation is matching, or you've pulled it from the existing extracted assembly, everything will just assemble correctly and everything will be in the correct place. And once you have everything completely disassembled, You could even compile that object and build your final library, and you wouldn't need this config at all because everything is the right size at the right offset, and you'll build the correct thing. We're a long way from doing that. We still need Splat to build our linker script for us, but hypothetically, they didn't have Splat when they were building the game originally. We could do the same thing. So the section that's missing and that has largely been ignored up until this point is the data segment. Data without a dot in front of it is going to be pulling from the extracted assembly. Data with a dot in front of it is going to be pulling from the C file. And we want to get our data eventually from the C file. And to do that, we need to find the offset of the data related to the shop. And temporarily, we're just going to split that segment for the shop and then slowly kind of bring that data in piece by piece. And so I'm going to look for that data. Right now, it's all going to be in this 0.data, just one big blob. And then I'm going to be looking for my list here. Oh, why aren't you here when I want you to be here? List. Didn't I just grep for you and didn't? Oh, I had it capitalized. So the other things I want, so I could split the data here and call this data eShop, and it would show up in a file called eShop.data.s, and that would be great. But there may be other data in here as well that I want to know about. So I'm also going to look at these functions that now are in the eShop segment. Not the Nintendo eShop, but the Soten eShop, E for entity, not electronic. I'm going to look at those functions and just get a rough idea of whether or not there's something before this data that I should pull out. We can look at the function while this is open and easy. We can look in here as well. And what data are we referencing here? We're referencing 425C, which comes way after all of this. So I don't think it's related. This might be BSS. This 18150, so this is in here. This may or may not be related. What else is in here? This is a little closer to the data that we're pulling. The big thing is this data used elsewhere? And if it's not used by other functions, then it's probably just related to the shop. If it is used by other functions, then it's harder to tell. And my my extract is a mess now, so we have it in a bunch of different places. But so we see this ed4 function, 420 function. There are a few things outside of the functions that we're looking at that use that data. So I'm not going to pull that in for now, and I'm going to focus on this 34C data. And I keep forgetting that I have case-sensitive compare on. This looks like one of the closer things. I'm going to look for this address too, just in case. And if this is in eShop as well, it's not. Then I would have to pull in all the other things that it's pointing to. But for now, I'm going to take just this inventory. And maybe it'll be something else later. So Mr. MIDI saying there's 2 data segments, one at 0 and a second at 2068. There can be as many data segments as you want. The data segments, really it just depends on how you split these up into different C files. And what I think is a good strategy is to try to locate the data as closely to the functions that use it as possible. And usually, but not always, the order of that data is going to follow the order of each of the code segments pretty closely. In this case, maybe not, and maybe it's a bad assumption that this is related data. I don't know. We'll just have to figure that out through experimentation. You kind of figure it out through as things get decompiled, and you see what some of these offsets are. But it's an art, ultimately. So after this inventory list is this second array or struct. I do want to see where that is too, if it's related to this eShop data as well. It is actually. I see that reference down here. So that's part of our data too. We want to include that, and then this D48 is that. That is included as well. And it looks like we're going into this 14DC, and that may or may not be referenced explicitly. A lot of times these addresses get baked in, and they're not really symbols that you would normally have, named symbols. So this is in the shop as well. I think it's a continuation of the array above. So really now, I could probably do a binary search or something like that to find this more quickly, but this 510, this is included as well. I see that reference down here. So really, I'm just trying to find what the last data is for the shop. And what's fun once you get this is you can come at this from either side. This is in the shop as well. So just continuing on. 2830. Oops. All right, so this one is not, 28 is not in the shop. So our next segment will start at 1528. We don't have a name for it. We don't have to give a name for it. One second. So I'm going to have a split. I don't remember where the start is. We'll find that again in a second. It's going to end at 1528 though. And I'm not going to give it a name. I'm just going to call it data, and Splat will name it based on the offset. And this one is going to be eShop. This one I'm going to just call data for now. Or give it the data type, because I don't have any of these things in the C file yet. And then go back up to it's going to start at 134C. And this won't change anything about how this gets compiled, only how it gets, any of the C files get compiled. It'll only change how it gets linked, and so I shouldn't have any issues here when I compile. I'm not pulling any of this stuff from C files. Something changed. Oh, data change. So when I look at this data, if I reopen this data now, all of that stuff below it is going to be gone. I'm going to have an eShop .data file here, and that will have the inventory. And then there also will be a file called 1528.data, which has everything after the shop. There's nothing that prevents me from splitting this somewhere like right in the middle. And if I did that, some of the data would appear in the file before, some of it would appear after. As long as it gets reassembled correctly, you wouldn't see that, and that happens from time to time. That data does get split in the middle, or like a word or a byte gets trimmed off the end of one segment when it should be there. Usually a segment should be at 4-byte alignment. And that can suck when you have to debug that and figure out why that data is not appearing correctly. So let's open our eShop data now that we have it. So like I said, there's two ways that you can go about importing this data. I'm going to get rid of that. I don't need it anymore. And I'm going to split vertically because I find that a bit easier. So we can work top down, or we can work bottom up. And what I wanted to get to originally was the store inventory. And so that's where I am going to start. I had this open. I had this open for the PSP. Let me see if I can recreate my search. I think that's unique enough. What's nice about the PSP extract is Splat couldn't figure out that some of this data is pulled on byte boundaries, and so it just extracted everything as words. And I find converting that to data is a little bit easier. All right, so PSP EU, PSP, let's go. Sometimes I write scripts to do this. Sometimes I write just regular expressions. I'll probably go the regular expression route for this. So this data is the same here, just on the PSP side, and there may be differences between the two. I'm going to pull this first inventory list, and then we can look down below and see if we can see the same pattern of structure. So we have this. This is pulled as shorts. I think this 00 up here likely is associated with this data up here. So this actually looks a little bit different. Oh, I'm looking at the wrong thing. I went too far down. There we go. All right, so we have our array here, 0, 0, 1, 0, 0, 0, 1, 0. Continuing on, here we have a 4 instead of a 0. So we might have something different there. Actually, no, this is padding. We have one word of padding that doesn't exist on the PSP side. So we'll have to figure out the padding does exist on the PSP side and not on the PlayStation side. So we'll have to figure out why that might be. And then our 004, our 3F, that's all there. And then we keep going. We have our word. So very similar data. We'll see if it ends up being exactly the same. So I'm going to take this, and what I like to do, and this is just me, do it whatever way that you would like. I like to paste this directly into my C file, and my C file is not going to compile now. Oh no, not the worst thing ever. And what I'm going to do is grab the struct from the function we were decompiling yesterday. And we called that inventory item. And the names are approximately correct. But there's probably some work that needs to be done there. And so I have my structure, and my symbol name is wrong. I have to use the symbol name. I'm going to have a, this is read-only data, so my array is going to be const. Oh no, it's not read-only data, never mind. My array is not going to be const. It probably is going to be static, because nothing outside of this file uses it. The type is going to be of inventory item, and it's going to be an array. And I can start my array up here, and I'll end it at the end of this section down here. Now I have all this, all these words in here that I eventually need to get rid of, and that's fine. The reason I pulled the PSP version is because it does something when it has pulled out the words, the data as words instead of bytes, I get the little endian byte order, which is perfect for the first two fields. I'm going to have to swap the data in the second two fields, and then I can use the value here of the last two fields. So what I like to do, and you can do this your own way, whatever way you'd like, I'm going to probably write an overly complicated regular expression to do exactly that. Pull these first two bytes and split them. Grab the first 4 bytes from here and use that as the item ID field. And then grab everything from here. So what does that look like? So first I'm going to look for a comment. I'm going to look for 6 hex characters. Unfortunately, Vim, I don't think it supports. Yeah, it doesn't support matching, so I'm just going to use wildcard. I don't care about the address, so I'm going to look for another set of hex characters as well. Then I'm going to look for, I'm going to start a match group and look for 2 hex characters. Another match group, look for 2 hex characters. And then not matching, look for more hex characters, look for the end of my comment. And then look for anything up to the hex marker. And that's going to be part of my next match group, which is going to look for 4 hex characters. And then everything until the end of the line. Oops. Then, next line, same thing, until I get to the end of comment marker. Dot word. And then I want everything that follows to the end of the line. Unfortunately, when you do a multi-line regular expression in Vim, it doesn't allow you to see what's going to match, but this should work. We'll see. So then, what do I want to do? I need a. I could do two things. I could put in field names. I'm not going to do that for this. I do like field names when building structs, but it's not necessary. So I need match group 1, match group 2, match group 3. Match group 3 has the hex prefix already, and so does match group 4. And a comma. And away it goes. And I missed the end of my match group. I missed the end of my last match group. You do it differently? I'll show you a different way to do it as well if this doesn't work. Pattern not found. There could be a couple reasons the pattern's not found. I can never remember offhand whether or not I should use a new line character there or not. So I can debug this with normal search syntax. Okay, so I do need a new line character. So let me go back to the search that I had and figure out where things went wrong. I'll just start over. Oh, here's where things went wrong. At the beginning of my line, I have white space, and I didn't account for the white space at the end of the line. All right, so we'll do everything in the comment, and then the word, and then our last match group. Wunderbar. Clear as mud. So that works, and now I think I remember what went wrong here. So I think I just need, there we go, 52 substitutions. What does it look like? It looks like this. Is it beautiful? It's glorious. Get rid of the labels. And now what? I should be able to compile this, and it will work fine as long as my C syntax is correct. And of course, I improved a liar. I'm going to go into the splat config. Because the data segment isn't being pulled from this file, I didn't think that there would be any issue, but apparently there is. So I'm going to look at the splat config for this, and I need to now tell Splat that I have this initial set of data being built into the C file. And so don't get it anymore from the assembly file, get it from the C object, the compiled object instead. So I'm going to look in lib. I want the eShop data. And I need to figure out where this ends. So I'm going to split the eShop data segment again. I have the start of this, so it's going to be a .data because it's coming from the C file. And then the data coming from the extracted assembly is going to start at 1D4, which is the first address after this array. And now I have to extract again to get the new linker script and build. And we fail, and that's okay. So our data is no longer in the eShop data, which is expected. And I'm matching all this other data, which is kind of funny with my... Oh, I didn't do that. So let's see what's wrong. Now, diff stage lib. So in this case, it looks like it is an alignment issue. I'm going to check where this started. So 1340 is going to be the address that I can look at. What do I have to... We're at 1340. All right, so what I want to see here, we're starting 03. Our data starts at, oh no, that's not the right one. That's not the right 1340. It's an imposter. So somewhere around 1340, I should get a sense of what might be going wrong. So here's 14C0, which is after, and maybe towards the end of the list. And so I'm just going to flip back and forth between those and see. So there's this 860600 at the end, and that is missing from mine, and that then breaks the alignment. So we need to figure out where that data came from or what it is. If it was something here or something else. Um, 14D, our data ends at 14D0. So I'm going to look at that address as well. Oh, lowercase 14D0. Here's 14D0. So this 14D4 is where the next data starts. And here's here's the problem getting your data from the PSP. It may be different. So unfortunately, I may have screwed up by choosing the PSP data because I'm trying to match against the PlayStation version. And that is how the cookie crumbles. Sometimes you do a bunch of work for nothing. So, unfortunately, all that is garbage. And that's okay. That's why we don't take shortcuts. That's why you always leave a note. So I'm going to revert this change. Can't get it from here anymore. Back it out. Start over. Let's load that again. Got to get rid of this data because even if it's an empty array, it does. Oops, make. It does introduce a data segment, and so we got to get that out of here. Okay, so I have to take the data from here. Mr. MIDI says that he would write a Python script. That probably is the smart thing to do. That probably is the smart thing to do. So now that I have bytes only and don't have the words, I'm going to get rid of all of the address information. And I'm actually going to line these up. Oh, come on. And now I'm going to do the same thing, but slightly differently. So if you hated what I did before, you'll love this. So matching a, we're going to match these hex values. And we wrote it once, we can write it again faster. So we can grab one, and the first and second byte are going to be relatively easy. We have a new line. We're going to do the same thing. And a new line. And now we have to grab 2 bytes, which nothing terribly difficult about that. It just all has to come in. How should I do this? I'll just grab the 2 bytes. Actually, we'll do each of these independently and then reconstruct them. For this one, I do want the hex prefix, the next one. I don't. So that gives us our first 4 bytes. And then we're basically going to do the same thing. So these are coming in little endian byte order, and so I have to be conscious of that as I'm going through. So what do I have? 1, 2, 3, 4, 6, 7, 8. 1 too many. I don't want the last new line because I want my replacement to just automatically get that. That's a little nicer, I think. So here I want first match, second match. For this third match, I actually want the hex marker from the second byte. So I'm just going to remove it from that match. So I want byte 4, and then I want byte 3. And the same thing for this last one. Hey, Blood Angel, good to have you. Thank you for joining us in chat. For 1 byte, endianness does not matter. That is correct. And so now these, for matches 5, 6, 7, 8, they have to go in the orders 8, 7, 6, 5. And oh, I missed a match. Somewhere in this garbage, I have an unclosed, I see, an unopened match group. Any BF programmers in chat? No, we had 56 lines. I want to say that there was only 58, or there was 58 matches before, but maybe I'm wrong. Maybe I'm wrong. Something happened down here. What's that? Okay. So now this time, this will really work for sure. No mistakes. Let's go. No! Why? We can't always win. All right, so the original one. I want to look at the start of this. It starts at 134C. And see if I have the beginning right. 134C. Sorry, I can't search for 134C because that's not going to show up. 1340. And right off the bat, I already have a problem at offset 8. So there's something going on that's not related to this. No, sorry, I'm at the completely wrong offset. There we go. Okay, so the original should have, so we have 1 byte, sorry, our data starts here, 05FF0000, and we're getting not that. So it does look like I did screw up on this byte order. So I'll have to debug that regex. So something else is going on. And unfortunately, I don't have any more time to debug this today. So when we come back next week, I'll tell you what I did terribly wrong along the way. It looks like I may have it looks like there may be something wrong with how I'm doing how the next match is being found. I'm gonna do one more thing, just to, yes. So now we have 49. That alignment looks better. I don't know how this would. 15. I don't know where this. So something else broke. That alignment looks much better though. I'm hoping that doesn't affect this. It did. Okay, I'll come back on Monday and tell you what I did terribly wrong, and how cursed my substitution method is. So you could be debugging a Python script, but why would you do that when you could debug a regular expression? I mean, seriously. Oh, that's what I did. That's not going to change anything. My, yeah, I definitely have something else wrong with my substitution. This, that byte ordering is not correct. So for the last field, I should have 1F40 is correct. 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the end of this next one, 0, 0, 9F. We should have 0, 0, 9F. So why is that? Where did I go wrong? I'm not sure. I'll come back on Monday and tell you how stupid I was about whatever I did that was completely stupid. Anyway, that is one way that I extract data. Took a long time to get there, and I'm out of time for today. But we will have the inventory list soon. Maybe writing a Python script is the way to go. I'm too pig-headed though to attempt that. So. What were we doing today? We were decompiling Castlevania Symphony of the Night. Learn more at soden.z.dev. Follow here along my journey. I'm just one of the people decompiling Symphony of the Night. Obviously doing it in the most brute force, stupid way you could do it, but usually having some success. Soden.z.dev has the status of the overlays that we've been working on. We were looking at the long library shop inventory today, and we'll probably spend a bit more time working on that. I'm going to try to get those splits in. And at least the splits have some value for other people who will be decompiling as well. I'm just, like I said, I'm just one person. This isn't my project. I'm just a contributor and like to stream this and make a fool of myself by failing to decompile. But that's how we learn. That's life. Is sometimes you win, sometimes you don't. And this day is not win. Monday will be a win day. That's all I have for you. Thanks for joining. Good to have you, Antoine. Good to have you, Orcam. Blood Angel, thanks for coming by. And definitely Mr. MIDI and Entropy Gravity Well. Nice to have you as always. Adios, everybody. Like, subscribe, chat, comment, do all the things, and I'll be back Monday. Adios.